Welcome to ClickMyProject.com. Now we are going to discuss about the project Symmetric Convolution and Adversarial Neural Network enables improved mental stress classification from EEG. Now we are going to discuss about the abstract of the process. EEG is most widely used signal to detect the various kind of diseases and the emotions of the persons. This process is aimed to predict the stress signal using the wavelet is presented in this process. At first, the stage of the project is the original signal will be the input like an EEGs are supplied to the pre-processing based on the filtering method to remove the noise from the signal. Then the pre-processed signals is transformed into one subbands like alpha, beta, gamma, theta and delta. At second, the features are extracted by means of the neural network algorithm named as the convolutional neural network. Then the feature vectors are extracted to generate the test feature from the signal. After generating the test feature, then the classification steps is used to classify the signal is stress or non-stress. Finally, the performance of the process will be evaluated to identify the efficiency of the process. Now we are going to discuss about the flow diagram of the process. This is the overall working flow of this process. The module consists of this project is input signal, pre-processing, transformation, feature extraction, classification, finally performance estimation. At first, the input signal is taken from the dataset. The dataset consists of the signal of both the stress signal as well as the normal patient signals. After getting any one signal from the dataset, we just move to the second stage of the project, that is the pre-processing. So in this pre-processing, we are mainly considering the signal limitation and then the noise filtering is carried out. So after doing the signal limitation and noise filtering, we just move to the third stage of the project, that is the transformation. We are transferring the original raw signal into one subbands like alpha, beta, gamma, theta and delta. So after converting the signal into one subband signals, we just have to extract the features from these signals. So the next module is the feature extraction. In this feature extraction, we have considered the feature extractions like time interval, peaks and convolutional neural networks. That is a kind of a deep learning method. Here we are using the 1D CNN method to extract the features from the signal. After extracting the features from the signal, we just move to the classification step. In this classification steps, we are applying the machine learning techniques to classify whether the input signal is stress signal or non-stress signal. So if it is a stress signal, it will indicate the signal as a stress, or else if it is a normal signal means it will be indicated the classification result as non-stress. After doing the classification, we just move to the final stage of the project, that is the pre-processing, feature performance estimation. So in this performance estimation, we have three kinds of performance estimations is there. One is accuracy, then the second one is the sensitivity, and the third one is the specificity. By using these three parameters, we can justify our process is efficient or not. Now we are going to discuss about the running procedure of the process. At first, open the Matlab 2019B and change the current directory. If you want to execute the process, just right click in the main_GUI.yum and select the option run. Once you selected the option run, the user interface will be open. In that user interface, you can see the several push buttons in the right hand side for the controlling purpose, and then the several axes and tables in the left side for the display purpose. First of all, click the button input signal. Once you click the button input signal, the dataset will be open. In that dataset, you have to select any one signal from the dataset. After selecting the signal from the dataset, the corresponding signal will be shown in the axis 1 with the title of input signal. Once we have imported the signal, we just move to the second stage of the project, that is the pre-processing. So once you click the button pre-processing, the filtering is carried out. Then the filtering response signal will be shown in the axis 2 with the title of filtered signal. Once the pre-process was completed, we just move to the third stage of the project, that is the transformation. Already in the flow diagram we have discussed about the transformation. Actually exactly what the transformation is, we have to convert the input signal into subbands like alpha, beta, gamma, theta and delta. So these are the signals we have separated here. It's shown in this axis. After segregating the channels, we just move to the feature extraction. Before that, the values of alpha, beta, gamma, theta and delta are shown in this table. So after extracting this one, the feature extraction also done. This is the values of feature extraction from each signals like alpha signal to gamma signal. So after extracting the features from this signal by using the convolutional neural network, we are going to classify the signal whether it is a normal or abnormal. First of all, it will classify the ID as signal ID 1. So once the signal ID was generated, we have to predict the signal whether it is represents to the normal signal or abnormal signal. So it is a normal signal, so the message box will be displayed as normal. Finally, the performance estimation. So in this performance estimation, we have three kinds of parameters: accuracy, sensitivity and specificity. Those values are shown here as well as plotted in the table format.